Standard 8 Mathematics, Chapter 16, Surface Area and Volume, Module 1. In this video, we'll study about volume of a cuboid and the curved surface area and total surface area of a cylinder. First, let us understand few concepts. First is cube. This following figure is the figure of a cube. Then the second figure, if you see, it is called a cuboid. And the third figure is called a cylinder. These solid figures, if you see, they occupy some space. Now, the measure of the space occupied by either of these solid figure, that space is called as the volume of the solid. So the space that these particular figure they occupy, that space is called as the volume of that particular figure. First, let us see cuboid and the formula to find the volume of a cuboid. If you see this figure, this is a figure of a cuboid. This is called as the height of the cuboid. This is called as the length of the cuboid, and this is called as the width of a cuboid. For a cuboid, if the height, the length, and the width is known, then we can use this formula to find out the volume of a cuboid. Hence, volume of the cuboid is L, that is the length, multiplied by B, that is the breadth or the width, into H, that is the height. So L into B into H will give you the volume of the cuboid. Let us see one example. Find how many liters of water will a cuboidal fish tank contain if its length, breadth and height are 1 meter, 40 centimeter and 50 centimeter respectively. So let us see the solution. So the water contained in the tank is equal to the volume of the tank. That means to find how much water that tank will contain will be very much equivalent in finding the volume of that tank. So let's see, the length of the tank as mentioned is 1 meters, and if we convert meters into centimeters, we know that 1 meter is equal to 100 centimeters. Okay, the reason we are converting meters into centimeters is because the other two lengths, that is the breadth and the height, are given in centimeters. That is the reason we are converting 1 meter into centimeters, and that makes 1 meter makes 100 centimeters, and the breadth is equal to 40 centimeters. Similarly, height, as it is mentioned, is 50 centimeters. So this is a figure, so the length, breadth and the height. Now we'll use the formula that we just saw, that is volume of the tank or volume of a cuboid. If you see, the tank is in the cuboidal shape. So the volume of the tank, that is volume of the cuboid, will be length into breadth into height. Substituting the values of length, breadth and height, so we get 100 into 40 into 50. That will give you 2 lakh cubic centimeters. Now the volume of the tank is 2 lakh cubic centimeters, and we have to find in this 2 lakh cubic centimeters how much liters of water will fit into it. So to do that, we just divide 2 lakh by 1000. As we know, 1000 cc or 1000 cubic centimeters can fit 1 liter of water. So 2 lakh cc's will fit 2 lakh divided by 1000, that is 200 liters of water. So in this cuboidal fish tank, we can fit 200 liters of water. So the tank will contain 200 liters of water. Let us start with the exercise that is practice at 16.1, the question 1. It says find the volume of a box if its length, breadth and height are 20 centimeters, 10.5 centimeters and 8 centimeters respectively. So as we know, a box will obviously be in cuboidal shape, so we will use the volume of a cuboid formula. So volume of the box or volume of the cuboid is length multiplied by breadth multiplied by height. Substituting the values of length, breadth and height, we get 20. into 10.5 into 8, and after multiplying we get 1680 centimeter cube. So the volume of the box is 1680 centimeter cube, or we can also write it 1680 cc, that's cubic centimeter. Let us see the second question. It says a cuboid shaped soap bar, it has a volume of 150 cc. We have to find its thickness if its length is 10 centimeters and breadth is 5 centimeters. So if you see this, I've just drawn a rough figure for a cuboid. This is a length, this is a breadth, and this is a height. So the length is given 10 centimeters and the breadth is given 5 centimeters. They've asked you to find out the thickness. So now if you see, the thickness of this cuboid will be same as the height of this cuboid. So that means, in short, we have to find out the height of this cuboid. So let's find out the height by using the solution. If you see, volume of the cuboid is given as 150 cc. The length of the cuboid is given 10 and the breadth is given as 5, and we have to find out the height, which is in turn be the thickness of this soap. So let us use the formula of volume of a cuboid, that is length into breadth into height, and substituting the values. Volume is 150, length is 10, breadth is 5, and height that has to be found out. So we have 150 is equal to 50 into h. Dividing both the sides by 50, we get h is equal to 150 divided by 50, which will give you 3. So from here you can say that the height of the soap will be 3 centimeters. Let us see question 3. How many bricks of length 25 centimeters, breadth 15 centimeters, and height 10 centimeters are required to build a wall of length 6 meters, height 2.5 meters, and breadth 0.5 meters? So now if you see in this question, the dimension of the brick is given in centimeters and the dimension of the wall is given in meters. So let us start with a solution. So we have to find how many bricks are needed to build the wall of this dimension. So we say let the number of bricks required be n. First we'll find out volume of each brick. So since the dimension, that is the length, breadth and height of the bricks are given in the question, we'll use that. So that is 25 into 15 into 10, which will give you 3750 centimeter cube. So this is the volume of one brick. Now let us find out the volume of the wall. So dimension of the wall to be built is also given. So the wall should have 6 meters in length, 2.5 meters in height, and 0.5 meters in breadth. So we'll find out the volume of the wall, that is 6 into 2.5 into 0.5, which will give you 7.5 meter cube. Now to find the number of bricks, we just divide the volume of the wall with the volume of the bricks. So the volume of the wall is 7.5 meter cube and volume of the brick is 3750 centimeter cube. So if you see, there is a difference in units. This is centimeter cubes and this is meter cube. So what we'll do is we convert the volume of the wall into centimeters, and as we know, 1 meter is equal to 100 centimeter. So this is meter cube. So 1 meter cube will be equal to 100 centimeter cube. So if you see, this is 7.5 into 100 centimeter cube divided by, so this is 100 cube taken here, divided by 3750. So after dividing this, we get 2000. So finally, we can say that 2000 bricks would be required to build the wall of this dimension. Let us do question number 4. So it says, for rainwater harvesting, a tank of length 10 meters, breadth 6 meters, and depth 3 meters is built. What is the capacity of the tank? So capacity means we have to find the volume of the tank and how many liters of waters can it hold. So let us start with the solution. It says the length of the tank is 10 meters, breadth is 6 meters, depth is 3 meters, We'll find out the volume as the tank is in cuboidal shape. So volume of the tank will be 10 into 6 into 3. That is 180 meter cube. Now, as we know, 1 meter cube will fit 1000 liters of water. So in 1 meter cube equal to 1000 liters. So 180 meter cube will be equal to 180 into 1000. So that will give you 1,80,000 liters. Now let us see what is the surface area of a cylinder. So if you see, this is a cylindrical container. It is in the form shape of a cylinder. And if you wrap a paper around this cylinder, okay, suppose I just wrapped a paper around the cylinder and I cut the remaining portion. Only I took that much paper that this entire cylinder is wrapped. And once you just open the wrapper, if you see, this wrapper is in the form of a rectangle. Okay, this wrapper is form of the rectangle, and if you find the area of this rectangle, that will be same as the surface area of this cylinder. So this area, finding the area, will be called as a curved surface area of the cylinder, which is equal to the area of the rectangle. And as we know, area of the rectangle is nothing but length into breadth. And if you see the length is same as the circumference of the base of the cylinder into height of the cylinder. Okay, so if we find out this when it was wrapped, it was a circle. So this length would be same as circumference of the base of the cylinder, and the breadth would be same as the height of the cylinder. Now we'll use a formula of circumference. So we know circumference of a cylinder is 2 pi r, and height of the cylinder we are just denoting it with h. So 2 pi r h is a formula that will give you the curved surface area of a cylinder. So it is 2 pi r h. Knowing these formulas, now let us solve some example sums. So total surface area of a closed cylinder. Okay, now in the previous one, if you saw, we just studied the curved surface area. So in that curved surface area, we did not take the bottom portion of the cylinder and the top portion of the cylinder. But when I say total surface area, so it is the curved surface area, that is the middle portion of the cylinder, plus area of the upper surface and plus area of the lower surface. So total surface area. And if you note one thing, upper surface and the lower surface both are circular in shape. So we can say that the total surface area is equal to curved surface area plus 2 times area of the circular face, because both of these are the same thing. So curved surface area formula we know, that is 2 pi rh plus 2, we are keeping it as it is, and area of the circle we know it is pi r square. Now from this expression, if you take 2 pi r common inside the bracket, you'll be left with h plus r. So from here we can say that the total surface area is 2 pi r into h plus r. Now knowing the two formulas, that is a curved surface area of a cylinder and total surface area of a cylinder, let us solve some sums from the practice set 16.2. So question 1 says, in each example given below, radius of base of the cylinder and the height is given. Then we have to find out the curved and the total surface area. So let's take the very first example that says r is equal to 7 and h is equal to 10. So here we will use the formula, that is a curved surface area formula is 2 pi rh, and if we substitute the values, 2 pi will take it as 22 upon 7 into r, that is 7, into height, that is 10. So this 7 and the 7 will cancel off, and you'll be left with 2 into 22 into 10, which will give you 440 square centimeters. So from here you can conclude that the area or the curved surface area of the cylinder is 440 square centimeters. Next, we also have to find out the total surface area of the cylinder, and as we know, total surface area formula is 2 pi r into bracket h plus r. Substituting the values, we have 2 pi, take it as 22 upon 7 into r, that is 7, and inside the bracket h plus r, that will be 7 plus 10. So this 7 and 7 will cancel off and you'll be left with 44 into 17. So 44 into 17 will give you 748 square centimeters. So from here we can say that the total surface area of the cylinder will be 748 square centimeters and the curved surface is 440 square centimeters. That's it for this video. The remaining portion we will complete in our second video, that will be our module 2. Thank you.